Okay, so let's try 5.3 number 34, where we have y double prime plus 4y prime plus 5y equals 1 plus 5x plus e to the 2x?
Yep.
Okay, first things first.
Wait, I think it's minus 4y prime.
It is minus 4y prime. Gosh, that would have been terrible. Okay. That would have been half a page of bad algebra. Yeah, probably. All right, so first things first.
Now we're going to homogenize.
Yeah. Okay, so check the homogeneous thing. So yh double prime minus 4yh prime plus 5yh is 0. Then what?
Alright.
R it. So you got r squared minus 4r plus 5 equals 0, which I think factors into
negative 5.
I think r minus 5 and r plus 1, maybe?
Wait a minute.
No.
They did.
Crap.
No.
Doesn't work. Next thing?
Well, that's
Just complete the square, right?
Yeah, I probably should try to complete the square or something. Like, really, I'm thinking 5 and 1, right? To get to 4. But they'd have to be mixed signs to get to 4, right? And if they were mixed signs, this would be a minus. So, crap, doesn't factor nicely. What do you do instead?
They did r minus 2 squared plus 1.
Okay, so you could notice that this is r squared minus 4r plus 4 plus 1 equals 0, right? And then this digit here is r minus 2 quantity squared plus 1 is 0. That's why it didn't factor, because it's complex, right? Okay, so I got r minus 2 squared is negative 1. So I think in the end here I got r is 2 plus or minus I. Okay. So what does that tell you about your homogeneous solution?
That one trick.
That one trick. Yes.
With the cosine and sine.
With the cosine and the sine thing. The cosine and the sine apply to the which part?
The I.
The imaginary part. So what's the coefficient on I there?
1.
1. So I'm going to have C1 e to something cosine of something plus C2 e to something sine of something. What are the somethings?
1x.
So the inside the cosine is 1x and inside the sine is 1x. And on the e's should be 2 x's.
And does it need to have another x up front because of the two of the same r's?
They're not the same. There's a plus 1 and a minus 1.
Yeah.
So when they come in conjugate pairs, right, when they're complex numbers, you get e to the real part times x, cosine of the imaginary coefficient times x, and then e to the real part times x and sine of the imaginary part times x. That's what I call it.
If this were like r equals 2 plus or minus 3i, then would it be
Then there would be
c1 e to the 2x cosine 3x?
Yeah.
Okay.
Yeah. So in general, that's if r is a plus or minus bi, then your solutions are y1 is e to the ax cosine bx, and y2 is e to the ax sine bx. This is a nice segue for today. We're going to need that. Cool, cool? Okay. All right. I found the homogeneous solution. Cool. Things I should be worried about.
Oh, the e to the 2x matches that thing?
Oh yeah, it seems like the e to the 2x matches these guys, right? You guys see that? Maybe I should be worried about my guess. Do I actually need to worry about my guess?
Not if you just do general u.
What root does e to the 2x go with? Like where would you get that? In an R, right? It would just come from 2, right? I don't have 2, I have 2 plus or minus I. So this e to the 2x is actually mismatched with these guys,
Oh, okay.
right? Because it doesn't have the cosine and the sine kicking around, I don't need to worry about that thing matching. So I need to get particular solutions for what parts? So what are the 2 parts? This is a permanent mark.
Split the right side into the polynomial and then also into exponential.
Oh, my hopes and dreams. Uh-oh, half of it works. So split into the polynomial part and the exponential part, right? And then you're going to have to make 2 guesses for your particular solutions. You guys all with that? So in teal here, I already found the homogeneous part, so I'm going to crush all of this stuff. So in teal, I need to guess yp is,
A plus bx.
yeah, polynomial of the same degree as that one. So I'm thinking a plus bx. I probably would have done ax plus b myself, but who cares? So then yp prime is what?
B.
B. And yp double prime is
1.
1.
Or is that, oh, it's a constant, so it's 0. I was thinking as a word.
Cool. All right, cram these in there. So if I shove all this stuff in there, I get 0 minus 4. What was yp prime?
B.
B. And then plus 5 times a plus bx. Very nice, guys. And that's supposed to equal,
1 plus minus.
no, just the teal part. So I'm not solving the homogeneous version. I'm using the superposition principle to solve just for the teal one. Maybe I really should have called this like yp1, right? But I'm writing this part in teal, and I'll write the other part in red, just to be confusing. So here, what do you get? I think I got minus 4b plus 5a plus 5bx equals 1 plus 5x. So equate the coefficients. So it seems like 5 is 5b. That should tell you what?
B is 1.
Okay? B better be 1 from the underlined parts. And from squiggledy parts,
Negative 4 plus 5a.
I got negative 4 plus 5a has to be 1.
A is also 1.
So that seems like a is also 1. You guys with us? Okay, so in the end here, I should add in teal, the teal particular solution is 1 plus x. You guys with me on that? Okay, so then I need to go hunt down the red solution.
I noticed you put that particular solution underneath the left side of your normal equation. Is that any coincidence? Like, are you pairing with that one on the left, or did you just write it there?
Oh, with this chunk?
Yeah.
No, I'm just putting it there.
Okay.
In the end, I'm going to add all 3 of these together. So now my hunt's going to be starting to find yp in red. So I'm going to dump all this stuff again, and I'm going to go after the red one. So the red particular solution, I should be guessing, let's see, I have an e to the 2x. So what should I guess? A e to the 2x? That's because that's a 0-degree polynomial times an e with the same exponent, right? Okay, so then yp prime should be a to the 2x
Times 2.
times 2. So I think I got 2a e to the 2x, And then yp double prime should be 4a e to the 2x. And then we should take those and shove them in there. So I got 4a e to the 2x minus 4 times 2a e to the 2x plus 5a e to the 2x. And this is supposed to equal what? E to the 2x. Okay, so divide through by e to the 2x's. Okay, so I think I got 4a minus 8a plus 5a equals 1.
So A equals.
Seems like a equals 1. Cool. Keep in mind the red a and the teal a from earlier were different, right? So when I found a is 1, what does that mean my red particular solution is?
E to the 2x.
E to the 2x. Okay, and then I'm using the superposition principle to add all this stuff together and say that my general solution, so my solution y, right, is the homogeneous part. So that one's got the c's in it. So I got c1 e to the 2x cosine of x, and then c2 e to the 2x sine of x. So that's the homogeneous part. That's really from the fact that there's a plus 0 up here, right? You guys all with me on that? And then to that, I need to add the
1 plus x and 1.
add the teal part. So I got 1 plus x. And then add the red part, e to the 2x. You guys with me on this? Okay, where are my constants for solving IVPs? Yeah, those are C1 and C2 here. You guys with me on that?
C.
Okay, cool. That is your general solution right there. Check that. Questions there? Okay, would this have worked if I had split the teal thing into 2 pieces?
I was just thinking about it, I think it would.
It should, right? If you did, instead of doing 1 plus 5x as one of your chunks, if you had done like teal 1 and teal 2.
Is that just like guessing A? And B?
Yeah, so for this one I would guess A, and for this one I would guess bx plus c. And in the end, those two things together, whatever you get, would add up to this 1 plus x. They might not actually be 1 and 1x.
Mhm.
They might be 2 and
X minus.
x minus 1. I don't know.
So
Does that
in
kind
order
of make sense?
in order to solve these, we can split up however we want.
Yeah, you can split up this right-hand side however you want. Make sure you're splitting across addition. If you split across multiplication or something, it won't work. But you can split up any way you like in terms of addition. And you always need to make sure that you get your plus 0 in there. So you got to solve the homogeneous thing first. And then whatever's left on the right-hand side, whatever your forcing terms are, you can chunk those up into terms however you like. Cool?